All right, so I'm going to do homework help here. No one had any questions about the first one. Did y'all have any questions about Monday's homework? Okay. All right. And then some people had questions about Tuesday. So since I'm recording the video, I'm going to answer some questions about Tuesday, okay? All right. So let's do the first one. So when you're solving a system of linear equations, you're basically seeing where the equations cross each other. So if the equations cross each other at one point, that one point, whatever it is going to be the solution. So if the point where they cross is 1, 2, then this is the solution because that's a point that's on both of those lines. So you graph the equations to see where they cross, and wherever they cross, that's the solution. If it happens to not cross at all, if the lines are parallel, that means they have the same slope, then this would be no solution because they don't share any points. And if perhaps when you graph it, you find out that the lines are right on top of each other, they share all the same points. This has infinitely many solutions, okay? Are y'all okay with that so far? Okay. So the bottom line is the solution is going to be the points that the lines share. If they share one point, that means that's a point that's on both lines. That's the solution. If they don't share any points, that means that they're parallel to each other. That's a no solution. And if they're right on top of each other, that's infinitely many solutions. So let me do the first one. The first thing you do to graph an equation is label your m and your b. Your m here is the number that's attached to the x. This is a linear equation. So you got a negative 3 over 2. Since it's a negative, the fraction is a negative, you can choose to put the negative on the top or the negative on the bottom. Do not make both the top and the bottom a negative because a negative divided by a negative is going to make your slope positive. So I'm going to have negative 3 over 2. So this is my rise, this is my run. I shouldn't have wrote them so close together. Okay, and my b is the number that has no variable attached to it, which is a positive 4. So now I'm going to find 4 on the y-axis. This is my y-intercept, so find positive 4 on the y-axis. This is 0, so I go up 1, 2, 3, 4. This is where I start, okay? Y'all all right? Okay. So now we're going to use rise over run to put other points on the line. So we have negative 3. That's our rise. That means you go down 3. Positive 2 is your run, so you go to the right 2. So it's down 3 and right 2. Down 1, 2, 3, and to the right 1, 2. Down 1, 2, 3, and to the right 1, 2. Okay? And then you connect your points. Now we're going to graph the other equation to see where those lines cross. So here my slope, my m is 3 over 2. This is my rise. This is my run. And my y-intercept, the number that has no variable attached to it, is negative 2. So we are going to find negative 2 on the y-axis. This is your y-axis here. This is 0. Negative 2 is down 1, 2. This is where I start. So my rise, I'm going to use my slope to put points on the line. My rise is 3. That means I go up 3 because it's a positive 3. My run is 2. It's positive 2, so I go to the right 2. So go up 1, 2, 3, and to the right 1, 2. This is where it crosses right here. Let's do it again. 1, 2, 3, 1, 2. If I want points in the opposite direction, I do it backwards. 1, 2, 3 down, and to the left, 1, 2. This is the point in which they cross. This point right here is positive 1, 2, and positive 1. So positive 2 and positive 1 is the solution. Any questions about this part? No? Okay. All right, so let's do the back. Wednesday. All right. I'm not gonna, well, I could probably do this, some of these on here. All right. So, who had questions about this one again? I forgot. All right. So, which one do you want me to do, babe? 20, 23 and 24? Okay. Anybody need to see any more of those? Colton, are you good with Wednesdays? 20? Anybody else? Okay. All right. So let's start with this one. All right. So what are the like terms here that you can combine? Yes, because they have the same variable as well as the same exponent attached to that variable. If those are not the same, both the variable and the exponent, you can't combine them. So you're going to add 5x squared plus 9x squared. So they're 5x squares and they're 9x squares. How many x squares are there? That's 14x squared. And you're supposed to do this on a separate piece of paper, but I'm going to do it right here, okay? And then you have this left. So all you do is just write, oops, sorry about the squared. Forgot the squared. And that's the answer there. Do you see it? Okay. Cameron, what about you? Okay. So now let's do 23. What coefficients are in front of the A's? 1. See that? So now, and in front of the B is also 1. So let's combine the terms that are alike. What terms are alike here? 1A plus 1A, right? What's 1A plus 1A? It's two of those A's. And then what, can we combine anything else? 3B and 1B. What's 3B plus 1B? So that's plus 4B. Make sense? Okay. So let's look at 24. What terms can you combine in number 24? Three y and 3y. Very good. What's 3y plus 3y? 6y. And then what else do we have? This negative 4y to the second. Okay. Got it? All right. Any others that you need to see? Okay. All right. So that's it with that. I'm going to go ahead and stop this video since I'm finished with the homework help. Okay.